Okay, guys, the last case I did, I presume it was distance from a point to a plane. Was that the last one that you guys did? This is pretty good parallel, but that was also an extension of the same case. I need to add into something here, guys. I think case 6 was the case that we did, distance from a point to a plane. I just need to add a few things to it. One very important thing is that if you're finding the distance from the origin to the plane. Now I'm not talking about any random point outside the plane. I'm talking specifically about the origin. Distance from the origin to the plane is straight away given by a dot n hat. You know what n hat is? It's a unit normal vector. So you directly do this and you'll get the answer for the distance from the origin to the plane. Sometimes you may want to find that as well. Sometimes that might be a requirement in the question or might just come in handy to solve some situation. If you're unable to remember this, your distance from the origin is a dot n hat. Some people have a problem remembering all stuff. So then you can just use the simple distance formula. Ax1 plus by1 plus cz1 minus d. We've done this formula before. You can use this formula and you can get the same answer. Yes, where x1, y1, z1, all three of them are 0. So when you place all three of them 0, you actually end up getting this. d over mod of square root of a square b square plus c square. Now if you remember, what is d? D was the right side of the Cartesian equation of the plane. And how do you get the value d in the first place? D is basically a dot n. If you remember the vector equation of the plane, and from the vector equation I showed you how the Cartesian equation comes out. So if you remember the right side of the equation, which is this d that we are calling, the right side of the equation, ax plus by plus cz is equal to d. This d that I am talking about is basically a dot n. If you remember, you go back and if you check your vector equation. So this is a dot n. Tell me, what is a square plus b square plus c square root? What is ABC? ABC are the components of the normal vector. Are the components x, y, z component of the normal vector. So if I do a square plus b square plus c square root, what do I get? Mod of n, mod of the normal vector. So this is basically n mod. What is any vector divided by its own magnitude? A dot n hat. So I'm just giving you a direct a dot n hat, but in case you forget that the distance from the origin is that, you can always plug in the x1, y1, z1 values as 0, you get the same thing.
Someone who can't remember a dot n hat even, how can I remember it?
You have no idea what kind of people you have. They do anything. They might forget the simplest stuff and they might remember the most complex. So it's fine. Each thing but okay. Are we good? This was one point I had to mention. Okay, there's another point which is also a very important point, and you might be using this in some question. You might be using the idea or the concept in some question, if not that particular aspect directly. The thing is this. See, there is a mod here. Why do you think there's a mod here? Because the answer could either come in plus or minus. Okay. Now, let's take the origin as an example. Guys, please just put it on silent. Let's take the origin as an example. Okay, the point that I'm trying to make is this. If let's say there are two planes, there is a plane, let me call that plane 1, and there's another plane, plane 2. And for both the planes, you find the distance from the origin to the plane. Let's say you have two different planes, you have two different plane equations, and I ask you to find the distance from the origin to the plane. Let's say one answer comes out positive, the other answer comes out negative. Let's say I'm not using the mod. I'm just using this. One answer comes out positive, one answer comes out negative. Now, what is the significance of both answers, one coming out positive and one coming out negative? The significance of that is this. If you have the two planes on either sides of the origin, your both answers for the distances will come out with different signs. One will come out positive, one will come out negative. So this by the way, guys, please put this on silent. Whose phone is this? Please put it on silent. Okay, so if your answers to the distance from the origin to the plane comes out with different signs for both planes, it is indicating the fact that both the planes are on either sides of that point. So if, let's say, I'll just take an example from the origin. If your a dot n hat value comes out different, has different signs for both planes, that means both planes are on either sides of the origin. So let's write down this point over here. So let me call this distance d1 and let me call this distance d2. So if d1 and d2 have different signs, then the planes are on either sides of the origin. And how we are calculating D, you know how we are calculating D. We are calculating D through A dot n hat. Are we good till here? And if both the distance values from A dot n hat, if both of them come out with the same sign, like either both of them are positive or both of them are negative, then both the planes are on the same side of the origin. So the next one would be if D1 and D2 have the same sign, then both planes are on the same side of the origin. You've made the diagram for this, I need to make the diagram for the other thing, other form. Can I scroll down? Yes. Easy, are you done? Okay, so for this one, I'll just make one scenario. Let's say, both planes are on the same side. This is what we're trying to say. So let's say this is D1 and let's say this is D2. So what I'm trying to say that if this is the case that both planes are on the same side of the origin, then the answer to A dot n hat would come out with the same sign. Either both answers are going to be positive or both answers are going to be negative. Now, I'm just giving an example. I'm just giving this example with respect to the origin, but it's not only for the origin. If you use the distance formula, let's say there are two planes, plane 1 and plane 2, and let's say there's a random point somewhere in space, random point q 1, 1, 1, let's say, for example. And I want you to find the distance of that random point 1, 1, from q to plane 1 and from that point to plane 2 as well. Using the distance formula, and obviously we will not use A dot n hat, we will use the whole distance formula. And the answers to both the distances come out to be of different signs. Like one comes out positive, one comes out negative. That means both planes are on either sides of that point Q. That point Q is somewhere in between the two planes. So this concept is not just for the origin. I'm just taking the origin as an example and explaining it, but this concept holds for any point. So this knowledge, this scenario, you might come across this somewhere and you might use this concept. That you might want to know where the point is or what's the relative distance between the two planes or whatever. So see, now here, if let's suppose I have both the values d1 and d2, and maybe I had worked it out in the earlier parts, and the next part of the question asks me, what is the distance between the two planes? What is the distance between the two planes? Now do you think I need to work that out again? If I have the values of d1 and d2 with me, can you tell me the distance between the two planes? The difference between the two distances, right? So if you have this knowledge that both planes are on the same side of the point, and you already have the respective distances from the point to both the planes, then you can always find out the distance between the two planes as well, if both planes are parallel. And if this is a scenario, and if I ask you over here what is the distance between the two planes, you would actually add up the magnitude of the two distances, and you said that's the d1 plus d2 would give you the distance between the two planes here. If in case the planes are parallel, I'm only talking about cases where the planes are parallel. Are we good? Any questions? This whole thing that I'm talking about is about parallel planes, by the way. I'm not talking about planes that are non-parallel, because non-parallel planes के case में point would not be on either sides, or both planes won't be on one side. This concept that I'm talking about is about parallel planes. Parallel planes being on either one side of the point or on either side of the point.
They can't be right.
Non-parallel planes के लिए concept ही नहीं बनता, because non-parallel plane is the same. We're talking about parallel planes. Is everyone okay till here? We can move on to the next concept. The next concept is called the common perpendicular. Okay, this is not a case, by the way, guys. This is a concept. I'm going to brief you on this concept and then I'll move on to case A. So the common perpendicular. If you remember, when we were doing P1, we had a discussion about multiplication of vectors. And when we were doing P1, I said that vectors can be multiplied in two ways, but we are doing only one way this year. We did only one way last year, and that was dot product, which we also call a scalar product. Why we call it a scalar product? Because the end result of the dot product is a scalar value. But vectors can be multiplied in two ways, or in other words, the multiplicative effect of two vectors can be discerned in two ways. Either you can look at it, it can have a scalar effect, or it could have a vector multiplicative effect. Now the vector multiplicative effect comes from the cross product of two vectors. So dot product yields a scalar value, and cross product of two vectors yields a new vector which is perpendicular to both the vectors that are being multiplied. So what I'm trying to say here is this, that let's say there's a vector A and there is a vector B, and we find the cross product of A and B in a way that I'm actually saying A cross B, taking the cross product in this sense. A cross B. That would give me, the result of this would be a new vector. Let me call the new vector C, which is going to be mutually perpendicular to both the multiplying vectors or both the multiplicative vectors. So let's say these two vectors are in some plane. There are two vectors that have been multiplied and they obviously will fall in some plane. So let's say this is that plane, just giving a rough sketch. Let's say this is the plane in which the two vectors are. So the cross product of the two vectors A and B will result in a third vector which would be perpendicular to that plane. So that vector C is basically perpendicular to both the vectors A and B. That would be the normal to plane, yes, that would be the normal to plane. So A cross B results in a C. Acha, scalar mein it didn't make a difference whether you did A dot B or B dot A, the answer was coming out the same because it was a scalar value. But in case of cross product, it makes a huge difference between A cross B and B cross A. Not a huge difference, but yes, there is a difference. The difference is this, that A cross B, if A cross B is a C, then B cross A is a negative C. So what I'm trying to say is this, if this is a sense that we are taking and A cross B is yielding a vector that is coming out of the plane, then B cross A would result in a vector that would go inside the plane, into the plane. Like if this is like coming out of the screen, that will go into the screen. It would be directly opposite to this direction. If you take the cross product in other sense.
There would be a requirement for the two vectors to be intersecting.
No, there's no requirement.
So
The only requirement, the only requirement for cross product to exist is that both vectors should not be parallel. Should not be parallel. And I'm coming to that. Okay, now how do I know it's coming out of the plane and it's not going into the plane? This particular case when they have taken.
if they're not parallel, then they're intersecting.
If
If they're screwed,
उसमें भी आप cross product ले
उसमें भी आ जाता है.
cross product because okay, we'll have this discussion. How do I know that C is in this particular direction that I have taken at this moment? This sense that we have created, A cross B, when it follows the rule called the Maxwell's rule. If you're a physics student, you will recognize this rule, the Maxwell's rule or the Maxwell's grip rule. So, yeah, so the Maxwell's grip rule would be if I'm taking this counterclockwise sense of cross product A cross B, then the sense of C would be coming out of the plane. So, or you can think of it as a screw being unscrewed, so it would drive outwards. If you would twist it clockwise, it would be driven inwards. So right now I'm going anti-clockwise, so the screw would be driven outwards, out of the paper, or out of the plane. And if I were to do B cross A, that would be driving the screw into the plane, so the direction would be equally opposite to it. So minus C would be this way. That is if I do B cross A.
Is it clockwise or anti-clockwise का बताया वो होगा हमें?
No, that comes from this sense. Are you taking A cross B or B cross A? So that would result. So if I keep the A there and B here, then A cross B would be clockwise. So that would be driving it inside. It depends on what sense you have taken as a start. I'm only referring to the sense that I have started with my diagram. Now, as A cross B is resulting in another vector C, so what would be the magnitude of this vector? We understand the direction of this vector. The direction is perpendicular to both the vectors A and B. But what would be the magnitude of this? A cross B magnitude is equal to A magnitude into B magnitude into sine of theta, where theta is the angle between the two vectors. This A B sine theta will give you the mod of the product of A cross B, the resulting vector that is coming out, mod of that. So clearly you know sine theta would become a 0 if theta is 0, or if theta is 180. In both cases, whether theta is 0, theta is 180, that's the case when I'm saying that both the vectors are parallel. So that means when both vectors are parallel, that's when your cross product is 0. So you can write this point as well. for theta equals 0 or 180, that is vectors being, both vectors are parallel. That is, both vectors are parallel. The cross product A cross B is equal to 0. For theta is equal to 0 or 180 degrees, that is, both vectors are parallel. The product A cross B is equal to 0. So A cross B is going to be 0 only in one case, and that is when the vectors are parallel to each other.
So dot product means when
Dot product means the other way around. Now see, you will have the maximum value for A cross B when your vectors are perpendicular to each other. Because sine is maximum with 90 degrees. Sine 90 is 1. So when your vectors are perpendicular, you have the maximum cross product coming in. But it's the other way around for dot product. When your vectors are perpendicular, your dot product is 0. And when your vectors are parallel, your dot product is at a max. You get the maximum value for the dot product when your vectors are parallel. Infinity, then A dot B directly. उसमें cos theta की value 1 हो जाती है. That's the maximum cos theta can offer. And whatever value comes out is the maximum value that you're achieving for that A dot B.
positive C is normal to the plane, right?
Negative C is going to be normal to the plane. It's just the one is coming. It's like if that is the sense that you're looking at, one is coming out of the plane, one is going into the plane. Both are parallel. Both are perpendicular to the plane. Are we all good till here? Any questions? Okay. Now, if you remember, that I dot, okay, if you remember, I dot I, J dot J and K dot K were all equal to 1. And dot product of dissimilar vectors was, dissimilar unit vectors was 0. I dot J was 0, J dot K was 0, I dot K was 0. Why? Because they were all perpendicular to each other. That's why the dot product was 0. It's the other way around here. In cross product case, I cross I, J cross J, and K cross K, all of them are 0. Because I and I both are parallel to each other, J and two J's are parallel to each other, two K's are parallel to each other. So the cross product is 0. Now what will be the result for the cross product I and J, J and K, I and K? For that, just remember this sense that I'm going to give you right now. This sense of the diagram, just remember this. I, J and K. So, I dot J, J dot K and K dot I. These will all give you positive results. I dot J is a positive K. J dot K, why am I saying dot? Cross product. What I'm saying over here is I cross J is equal to K. J cross K is an I.
So this is only when they are parallel. So this is only when they are parallel.
No, I and J and K are not parallel to each other. They are all three mutually perpendicular to each other. Parallel to two I's are parallel to each other. Two J's are parallel, two K's are parallel. So therefore their answer for the cross product is 0. I and J are perpendicular to each other. So their cross product is going to be maximum. What would I cross J give you? I cross J is going to give you a third vector which is going to be perpendicular to I and J both. Which vector is perpendicular to I and J both? The vector K. So it results in the vector K. What would be perpendicular to J and K? So J cross K gives you an I. What would be perpendicular to I and K? So K cross I would give you a J. So K cross I would give you a J. Now the other way around. Now you know the other way around will give you the same vector but in the opposite direction. So J cross I gives you a K but with a minus. And I cross K gives you a minus J. K cross J gives you minus I. So I'm just putting a minus sign here and putting pluses outside just to show you the sense that we are taking in it. So J cross I will give you a minus K. I cross K will give you a minus J. And K cross J will give you a minus I. So if you just remember this diagram, clockwise and anti-clockwise. Clockwise positive, anti-clockwise negative. Just remember this and then you will exactly know what to do. Are we all okay till here? Any questions? Any confusion? Are we all good?